The following presentation was recorded at the Mendito Amplification Annex of Maggio Music Center in Brooklyn, New York. Welcome to the workshop. This video is action-packed. Keep watching and you will be rewarded with both wide-angle and close-up action shots of actual work being performed. You will be entertained by above-average but still mediocre guitar-playing demonstrations. Together, we will share in the triumphant rebirth of this vintage American classic vacuum tube guitar amplifier. In the previous installment of this video series, I disassembled this 1964 Gibson GA5T Skylark amplifier. It put up a fight, it drew blood, but I tamed this razor-sharp beast disguised as a songbird. In the final scene, I left you with a view of the internals of this amplifier after disassembling it. I explained the challenge of improving its tone that I have been tasked with. In this video, I pick up the gauntlet, put it on my hand, I raise my clenched fist high, and I exclaim, "I will prevail." I am analyzing the circuit and the physical layout, and first things first, I need to take this outside and clean it out with some compressed air because it's really disgusting. Here is the correct and complete schematic diagram for this 1964 Gibson GA5T Skylark amplifier. I propose to make several physically minor but sonically major component modifications. Another improvement that I was intending on making was to mount this cord better. I was going to add a cord gland that this top part tightens onto the chassis, and then you put the cord through there and you tighten it down. It actually grips the cord and it's a strain relief. It protects the cord from the metal chassis, but this is not going to clear where that slides in, and I don't want to drill a new hole. So upon further examination, there is actually a plastic insert protecting the cord, and then they also put some wire ties to at least keep it from pulling out, but it still spins around. So what I think I'm going to do is just get some silicone RTV and glue that down to the chassis. In my opinion, an opinion commonly held by many amplifier aficionados, enthusiasts, or amp whores, as my rockstar friend John likes to refer to himself, the speaker and cabinet are the most important and defining components of a guitar amplifier. During the modification and subsequent testing process, the biggest mistake that I could make would be to plug this amplifier into a different speaker cabinet that I have here in the shop. I am going to reassemble this cabinet without the amplifier chassis and use the original speaker and cabinet during this testing process. While I work on this, let's listen to an audio demonstration of the amplifier before modification. I cleaned the dust and debris out of the chassis with some compressed air and a brush. I did the best that I could. I decided not to use any isopropyl alcohol. I'm going to use that sparingly and as needed. I was analyzing the circuit, deciding what to do next, and I noticed that the heater circuit does not have a center tap, and they did not add an artificial center tap anywhere. What they did, if you look on the schematic, was they referenced one wire directly to ground, and that actually occurs right over here, where they take the end of the chain of the heater circuit and they put this right to ground. So I am going to eliminate this wire, and I'm going to add this terminal strip here at this grounding point, and I'm going to install two 100 ohm resistors to these terminals. I'm going to remove this wire from the rectifier tube and install that here to each end of the artificial center tap, and then I'm going to run two new wires to the rectifier tube. I'm going to use the remaining open terminal to connect the neutral wire and the wire into the transformer so that it's not just dangling around like that. While we are watching this super speed installation of the artificial center tap, let's talk about some things and get to know one another. How are you today? If you have any questions or comments that you would like to share, please go ahead and utilize the comments section of this video. Send me an email or give us a call at the store. If you have an amplifier or instrument that needs repair, we can help. You can send it to us, or if you are nearby in New York City, stop by and pay us a visit. We also have a music school on location. We are one of the last family-owned and operated music stores in New York City. I met the Maggio family in 1988 when I was in grammar school. I was a student at the music school. Mike Maggio Jr. taught me how to fix musical instruments, mainly electric guitars, as well as basic electronics repair. I have been an unofficial member of the family ever since. We have a genuine passion for musical instruments, so I decided to start this YouTube channel with the goal of sharing our passion with you. Let's get back into this Gibson amplifier and talk about the speaker again for a moment. This 1964 Jensen P10RL speaker was the crown jewel feature of this Gibson GA5T amplifier. I am glad that I reinstalled it into the cabinet for testing, because when I first tested the amplifier, there was a metallic rattling sound. I thought that maybe it was coming from the amplifier chassis, but the sound is still there, even though I have the amplifier chassis on the workbench. I am also glad that I made some high-quality demonstration recordings for this video. Can you hear the static and crackling sounds as I am playing? I have determined that all of these sounds are actually coming from the speaker. The speaker itself, not the cabinet. The speaker is mounted tightly, and the baffle board is mounted securely into the cabinet. I know that some of you amplifier experts out there are going to question me on this, so yes, I tested the amplifier using a different speaker and cabinet. The crackling sound is not coming from a bad carbon composition resistor. It is not from a bad tube. There are no bad solder joints. The problem is definitely with the speaker. With that said, the speaker still sounds really nice. Yes, the speaker is lacking a bit of treble. It is not very efficient, so the amplifier is not particularly loud, but the tone is still really nice. In fact, my next-door neighbor Ron heard me playing and sent me a text message saying that he thought that the tone was absolutely amazing. This is a good message to get from your neighbor when they hear you playing electric guitar from outside of your house. Before we move on to the next scene, I would like to mention that all of the audio demonstrations on this video were recorded using this Gibson GA5T amplifier and the original Jensen speaker. The only thing in between the guitar and amplifier is a 10-foot instrument cable. No effects have been added in post-production. This is how the amplifier actually sounds, and in my opinion, this is the way that all amplifier demonstrations should be presented. Our new artificial center tap is installed and it works perfectly. I took the heater wires that fed the rectifier tube, off of the pilot light, and I move them to this new terminal strip, and I've installed two 100 ohm 1 watt carbon film resistors to ground. So now we have a nice balanced reference to ground. I matched the wiring color. It actually looks like it came from the factory like this. This is actually new wire, it's just not dirty. And so that works perfectly. I installed the neutral from the power cord to where it connects to the transformer here instead of it hanging and bouncing around in the chassis. So that's complete. We're going to move on to the next modification. The next thing I would like to focus on are the power tubes, the two 6AQ5 power tubes in push-pull. Here we have a shared screen resistor. This is a 1000 ohm carbon composition resistor. It goes from the rectifier to the screen grid here, joined to the screen grid here, and it also feeds the second 6EU7 tube, which is the cathodiene phase splitter and tremolo tube. I'm not fond of the circuit. This is a low cost, it was made to be cheap. I would like this to have two separate screen grid resistors. I would put 470 ohm screen grid resistors. I would put a separate voltage dropping resistor. I had originally devised a plan to add some terminal strips here, and I was going to do all that, but I decided against it. This has drifted out slightly to about 1200 ohms. It's good enough. It's not burned. The voltages are pretty close to what is specified in the schematic diagram. So in the interest of leaving the amplifier as original and unadulterated as possible, I'm just going to leave that. It should have some longevity. I don't really see that burning out and causing catastrophic failure. So the next thing I'd like to focus on, and before we do that, here is that 1000 ohm shared screen grid resistor. Now the next thing I'd like to focus on is the cathode bias resistor, which is a shared cathode bias resistor. It's supposed to be a 270 ohm resistor. It's probably 2 or 3 watts. I'm not exactly certain. And that's also supposed to have a 20 microfarad cathode bypass capacitor. So here is our 270 ohm shared cathode bias resistor. It's a little bit out of spec at about 287 ohms, and it's not burned, so we'll call that acceptable. Again, I had devised a plan of adding some terminal strips here, and I was going to put, 5 watt 470 ohm cathode bias resistors for each tube, and I was also going to add a separate cathode bypass capacitor to each tube, but I decided against that. Again, I want to leave the amp as original and unadulterated as possible, but still make some improvements so that it's more usable and that it just sounds better. So what I am going to do is I'm going to add in a cathode bypass capacitor, and I would like it to have more capacitance than just 20 microfarad. So I have this 100 microfarad, 100 volt F&T electrolytic capacitor. There is a ground right here, and I can put the anode end right to the cathode on the tube on the left, and they're joined together by this wire, so they will share this cathode bypass capacitor. I'm going to install this temporarily, and we're going to hear a before and after. Now we are going to focus on this cathode bypass capacitor. Right now it's not connected. Now we are going to use this alligator test lead. The capacitor is here. It's attached to the positive side of the cathode bias resistor, and on the other end is attached to the positive side of this capacitor. Now we're going to ground the capacitor with this white lead, and we'll try it again. So the difference is not extremely audibly profound in a cathode biased push-pull amplifier in an AB amplifier. On a single-ended Class A amplifier, it's much more pronounced tonally, as well as how it feels and how stable and really consistent the signal is. So what I am hearing is that it's a little bit tighter and less muddy with this capacitor installed, and there's less swing in the audible volume, and it feels kind of tighter to play. So I'm going to install this capacitor now. I have this cathode bypass capacitor that's being shared by these two 6AQ5 power tubes soldered in place, and I feel like it makes more of a difference soldered in place. I feel like the amplifier has more power and it feels nice and tight. It's picking up some noise with the chassis open and the guitar right near it and some lights on, so I think it sounds great. Now we're going to move on to the next modification. Our next modification will occur right here. This is the second stage of the first 6EU7 tube, and this is the coupling capacitor that couples it to the cathodiene phase splitter of the second 6EU7 tube. This is a 250 microfarad capacitor, or by today's nomenclature, it is a 250 picofarad capacitor, and this is what you would normally use in something like a Fender tone stack for the treble control. Why Gibson chose to use this as a coupling capacitor, I really don't understand. But if you look here on the schematic, here it is located in between two 47 kilo ohm resistors, and I guess they were trying to attenuate some of the treble before this, and that would definitely account for the very thin sound that this amplifier has. So we are going to test the amp one more time with this in place. Then we're going to remove this, and we are going to try in its place a 47 nanofarad or 0.047 microfarad coupling capacitor. See if I can get that to focus on there. And we're also going to try a 22 nanofarad or 0.022 microfarad coupling capacitor. This is our final audio test before removing this 250 picofarad, or as noted on the schematic, 250 microfarad coupling capacitor. We have replaced the 250 microfarad or picofarad coupling capacitor with a 22 nanofarad or 0.022 microfarad capacitor. Let's check it out and see how it sounds. I think it has a nice full sound. Let's try out the 47 nanofarad or 0.047 microfarad capacitor. Sorry if my playing was a little bit off. I was kind of thinking as I was playing, and I was kind of biased towards the 22 nanofarad, the 0.022 microfarad, thinking that that would be ideal, but I think I like this one better. It has a nice big full sound, it has a lot of gain, and I think this is the one. So I'm going to install the 47 nanofarad or 0.047 microfarad capacitor. Our 47 nanofarad or 0.047 microfarad coupling capacitor is soldered in place, and it sounds great. It really does. It's got some real nice low-end growl. Sorry, the direction the guitar is facing in is picking up some interference from the PC in front of me. It's really got some bottom to it, but not too much. This is what the amp was missing. It really sounds great. Let's move on to the next step. Another improvement or modification I'm going to add to this amplifier is a negative feedback loop. So this is going to be achieved by using this terminal strip that's already here. This is the positive output wire from the output transformer, and the center is already grounded right to the chassis. There is an open terminal right there. So I'm going to install a 10K limiting resistor, 1 watt 10K limiting resistor, and then I'm going to put a wire here and attach it to this 250K audio taper potentiometer. And I'm going to mount that to a screw that's already here on the chassis and use this bracket. And what this is going to allow me to do is I'm going to drill a hole into that, and I will put the knob, which is right here. And when you put this rear panel back on, this will be relatively innocuous from the top and from the front when you're standing. But when you're using the amplifier, you can reach down and you'll be able to actuate this control. And then the output from that control is going to go through a hole already in the chassis from where the wires come from the output transformer. And we're going to insert the signal right here into the cathode of the second triode on the first tube. And that will give us our negative feedback loop. I had originally proposed using a 250K audio taper potentiometer along with a 10K limiting resistor. I have revised this proposal to a 250K linear taper potentiometer and a 30K limiting resistor. We are going to achieve this negative feedback loop by taking the positive output signal going to the speaker and inserting that into the cathode of the second triode in the first 6 EU7 tube. We are going to attenuate the signal with a minimum value 30K resistor, and in series we're going to add that 250K linear taper potentiometer so that we can adjust our negative feedback to a minimum of 30K and to a maximum of approximately 280K, which would pretty much remove that negative feedback signal from the circuit. So this will give us a nice sweep and the ability to completely remove the negative feedback loop without a switch. I have our adjustable negative feedback loop all set up here. I mounted this potentiometer to the chassis. I didn't make this hole, these holes were here, so I thought I would take advantage of that. I have the 30K limiting resistor here, and $30K is just too low. It has a weird little bit of distortion going on. But then when you sweep, the difference is not very pronounced. I don't think that this adjustable negative feedback loop circuit is going to work out, but what it is going to do is allow me to choose a set resistor value. So what I'm going to do is I'm going to leave the potentiometer in that position, and keeping the limiting resistor in series, I'm going to measure with my multimeter what this resistance is, and then I'm going to choose the closest value resistor that I have and just use a fixed resistor in this circuit. I'm reading almost 79K as what I felt was the best value. The closest resistor that I have, though, is a 75K. So I'm going to install the 75K limiting resistor, and we will test it out again. Okay, we have our 75K negative feedback limiting resistor installed by itself, no potentiometer. So the effect is subtle, but it's stabilizing. It takes away some of the fizziness. It tightens up the bottom. I think it's perfect. I'm going to install the negative feedback loop with this 75K limiting resistor. Here is how I'm going to install this negative feedback loop into the amplifier, and I'm going to do this in the least destructive manner as possible. This is the output transformer, and the output wires go to this terminal strip. The ground is in the center, and this is the positive, and this is an open terminal. So I'm going to take this 75K ohm limiting resistor and jump from the positive to the open terminal. And then I'm going to install a yellow wire. Yellow is cathode for the EIA chassis code. And I'm going to run this wire flat across the chassis to this rivet here. And the rivet is actually hollow. And I can poke right up through and just install right to the cathode right there. The next modification that we are going to make to this amplifier is to change the coupling capacitors that feed the two 6AQ5 power tubes. And they are located here and here. These are a pair of 0.01 microfarad or 10 nanofarad coupling capacitors. They have a minute amount of DC leakage, and although that is acceptable, I feel that the amp still sounds a bit flat and gutless, so I am going to raise this value to a pair of 0.022 microfarad or 22 nanofarad coupling capacitors. In this presentation, I have focused a lot on coupling capacitors. The value of each coupling capacitor is particularly important in this amplifier because there are no equalization controls. These controls are also colloquially known as a tone stack. A tone stack is a group of different value coupling capacitors, each paired with a potentiometer wired as a variable resistor. This makes their respective impact on the audio signal adjustable. A coupling capacitor links the output of one amplifier stage to the input of the next amplifier stage. They allow the alternating current audio signal to pass through, but at the same time they block the direct current power source from the previous tube amplifier stage. This prevents the DC current from passing onto the input or control grid of the next tube amplifier stage. The simultaneous existence of alternating current and direct current in certain portions of a tube amplifier circuit is a topic for a future and more in-depth discussion. The important thing to know is that the term DC leakage means that a capacitor is no longer doing its job of preventing DC current from passing through it. The value of a coupling capacitor, measured in a unit called farads, determines the frequency range that is allowed to pass between the cascading stages of amplification. Larger value capacitors allow more low-range frequencies to pass through. Use a capacitor too small, and you will have very little bottom end. Use a capacitor that is too large, and the results will be an amplifier that is too bass-heavy and muddy sounding. You can also create a condition known as blocking distortion, where the bass signal is too large and it actually overwhelms the next stage of amplification. This can cause it to intermittently stop amplifying the signal, a condition known as cutoff. When a very clean tone is desired, larger coupling capacitors are preferable in order to achieve a full-bodied and well-rounded tone. In a very high gain amplifier, however, small coupling capacitor values are preferable in order to achieve the best tone, without the signal getting muddy or causing blocking distortion. Another term that I have used during this presentation is negative feedback loop. Simply put, a negative feedback loop feeds an attenuated opposite phase signal from a later amplifier stage back into a preceding amplifier stage. This opposite phase signal has a neutralizing effect that flattens out the signal, increases frequency response, and makes the amplifier more linear. I think that you can tell from my audio demonstration that the negative feedback loop installed into this Gibson amplifier made the clean tone sound more compressed, and it made the overdriven tone sound tighter and less ragged. It is also important to mention that each stage of amplification creates a mirror image opposite phase signal. If you have any questions regarding topics discussed or terms used in this video presentation, please leave a comment below. Let's try out these new coupling capacitors. sounds pretty great. This brings us to my final modification on this amplifier. I am going to address this tremolo circuit. In my previous video featuring this amplifier, I had mentioned that I thought that this tremolo was a novelty and a gimmick. And it really is in its current incarnation. It's just too much. It has too much of a dramatic staccato muting effect that makes it not very musical or usable. So we are going to make it a little bit more musical and usable. And we're going to, right here, there is a resistor to ground that kind of attenuates this effect. We are going to reduce the depth of the effect by adding a 470 kiloohm resistor in parallel, and that occurs back over here. So we're going to attach it here and to ground, and this will dramatically reduce that muting and staccato effect that makes this rather, like I said, gimmicky and unusable. And this will actually make it sound lavish and lush and musical. It's going to be quite nice. Let me set this up. Now, I think that reduces the effect to a point where it's still nice and pronounced, it's still period correct sounding, but it doesn't completely ruin it. It's there, it's prominent, and at the same time it doesn't allow it to be just too much and too exaggerated. So, unfortunately, this doesn't have a control for this. If this had another potentiometer mounted on the front, they could have integrated this into the circuit, which I do believe they did on the next year that this amplifier was made. The front panel and all the controls are completely reworked, and it has a tone stack, and it has this frequency and an intensity control next to that. So this is my solution for what we're working with. An important thing to understand about this amplifier is that this model was originally released in 1963, and it carried over into 1964. In 1963, people were still listening to doo-wop and surf music. Wipeout by the Surfaris was one of the most popular songs of 1963. Over-the-top reverb and tremolo or vibrato effects were still really cool. Everyone wanted to be able to make that crazy surfer sound at home. This exaggerated tremolo circuit was simpler and cheaper to manufacture than a reverb circuit, but you could still achieve that over-the-top surf rock sound. In February 1964, the British invasion happened, and it changed American popular music forever. Sure, many more great songs using a vibrato or tremolo effect were released after 1964, but now it was imperative to be able to really control it. The 1965 Gibson GA5T amplifier featured a new depth control along with the frequency control for the tremolo circuit. It also featured a bass and treble control. The name Skylark was omitted from the front fascia. I did try out a set of new old stock tubes in this amplifier. The new tube set made no difference at all, so I did not include that audio test segment in this video presentation. I found two new old stock RCA 6X4 rectifier tubes in my collection. My grandfather gave me these tubes over 30 years ago. I needed more 6AQ5 tubes, and I have never had 6 EU7 tubes in stock, so I ordered 2 of each. Here is the motley set of tubes that I have assembled. One of the new old stock 6 EU7 tubes that I received has a bad triode. As a policy, we do not just replace parts unnecessarily, so I put the original tubes back into this amplifier, but I will save these new tubes for a future project. We have reached a point where many of the new old stock tubes that are still available are either completely defective or they test outside of design specifications. Most of the premium stockpile has been exhausted. Many used tubes are being passed off as new old stock. There are also a lot of counterfeit new production tubes being sold as genuine original tubes. I'm not saying that it's impossible to obtain a good set of new old stock tubes, but it is becoming increasingly more difficult. I am still awaiting a reply from our customer as to whether they want to replace the speaker in this Gibson amplifier. If we do replace the speaker, I will try to make a quick follow-up video presentation for your viewing and listening pleasure. This concludes my 1964 Gibson GA5T Skylark Rejuvenation Project. Thank you very much for watching and for listening to my audio demonstrations. Please like this video and subscribe to our channel. If you have any questions or comments, or if you have a musical instrument or amplifier that needs repair, please utilize the comment section below. Send me an email or give us a call at the store. We will release more video presentations like this one very soon. Thank you again from all of us here at Mendito Amplification and Maggio Music Center.